As an example of finding the volume of a cylinder, we're going to find the volume of this rather large candle. Now, in the movie about prisms, I did say it's actually very difficult to find perfect mathematical shapes in the real world. And indeed, that's the case with this candle. It's a pretty good cylinder from here to here, but there's this rather knobbly bit on the end here, which I'd love to get a sharp knife and just chop it off. But you know what would happen, don't you? The power would fail tonight. My wife would say, "Oh, where's that large candle?" And I'd be, and that would be the end of me, wouldn't it? So we're going to have to leave it there, I'm afraid. When we've done that calculation, we're also going to find the density of this wax, because that turns out to be quite interesting too. Now, to find the volume of a cylinder, we need to know the area of the end. Obviously there's some pi r squared involved there, and the length. So the first thing we're going to do is to measure the diameter, which turns out to be 7.8 centimetres, and the length, which is 18.5 centimetres. The first thing to do, of course, is to find the area of the end. So we're going to need the formula area of end equals pi r squared. We know that the diameter is 7.8 centimetres, so the radius must be half of that, 3.9 centimetres. Now, don't go using the diameter in this formula. That's quite a common mistake in the exams. And notice, by the way, it's much easier to say area of end than cross-sectional area. So this gives us area of end equals 3.14 times 3.9 times 3.9, which is 47.7594 square centimetres. Notice I've used 3.14 for the value of pi. If you want to repeat this calculation and use your pi button on your calculator, you will of course find slightly different figures deep down in the decimals. Now, the volume is the area of the end multiplied by the length. So that's 47.7594 multiplied by 18.5, which comes to 883.5489 cubic centimetres. We now correct this answer to something sensible, such as three significant figures, giving us 884 centimetres cubed. Notice I'm writing correct to three significant figures to show the examiner what I'm doing at this point. So that's the volume calculated. Now, what about the density of this wax? Well, obviously to do this, we need the mass of the candle as well. So I'm going to take out my trusty scales here, set them to 0, put the candle on, and that is 743 grams. To get the density, we divide the mass by the volume. So that's 743 divided by 884. And that comes to 0.8404, and again we'll correct that to three significant figures, giving 0.840. But what about the units? Well, we divided grams by cubic centimetres, so the units are grams per cubic centimetre. In other words, every cubic centimetre of this candle wax has a mass of 0.840 grams, because that's exactly what density means, of course. But just a moment, 0.840 is less than 1. And if you've done a little bit of physics, you'll know that that means that this candle should float. So it's off to the utility room. Well, here we are in ye olde utility room. There's the sink of water. There's the candle. Let's see what happens. Lo and behold, it floats. Isn't mathematics a wonderful thing?